Okay. Uh, Today class we will do some problems based on the uh, um, Rolle's theorem. Okay. First we will do this question. This question one. The function if is defined in 0, 1 as follows. This function is defined by like this: 1, 2. When 0 less than equal x less than equal half. When half less than equal s less than equal 1. So that f of x satisfied none of the condition of Rolle's theorem. Okay, none of the condition of Rolle's theorem. You already know that. What is the Rolle's theorem? Right, f is a function from one of the particular set A, subset of real number A to real number, it's a real value function. F is differentiable in this interval a comma b, and f is continuous in the closed interval a comma b, and f of a equal f of b, then they are like this: c belong to this closed interval, so open interval a comma b, such that f dash of c equal 0. The c belong to open interval a comma b. Okay, you already know that the theorem, Rolle's theorem. This question they asked so that f of x satisfied none of the conditions of Rolle's theorem. Therefore, your three conditions are, you want to show that the three conditions are false. Differentiable condition is false, continuous condition is false, and f of a not equal to f of b. That means here, this f of 0 not equal to f of 1. Okay, f of 0 not equal to f of 1. Okay, these things are, you want to show that for this question. You know that suppose f is differentiable, then f is continuous. For ligation part, f is discontinuous implies, okay, f is discontinuous implies f is non-differentiable. Okay, non-differentiable. Okay. First, you want to find the, you want to show, right? You want to show first f is discontinuous. Let's take the left limit for this one and right limit for this one. For a left limit, okay, for a left limit, s length to half minus means this interval inside. Function take the value 1. Therefore, again, this 1. Limit of right limit of f of x. This one is I think 2. Therefore, because half plus in this interval. So in this interval. therefore is 2. Take the value 2. The upper limit is not depend on x values, they have only constant value 2, they have a limit also 2. Okay. 2. So left limit not equal right limit. Therefore f is discontinuous. Therefore f is discontinuous. F is discontinuous, right? What is the point? At the point half. Half, this obviously this one belong to 0, 1. Okay. This one belong to 0, 1. It's point. Okay. At the point, okay, sorry. It's not clear, no? At the point. F is discontinuous at the point half belong to 0, 1. Therefore, F is different. F is not differentiable, non-differentiable. Okay. F is non-differentiable at, okay, F is not differentiable in the interval in 0, 1. The open interval 0, 1 subset of this interval, therefore F is non-differentiable in open interval 0, 1. Open interval 0, 1. What is the f of 0? Next, f of 0 means here is 1. F of 1, I think 2. From this one, f of 0 not equal f of 1. 3 conditions are false. Okay? 3 conditions are false. That is your question, right? So that f of x satisfied none of the condition of Rolle's theorem. Okay? Hence, each of the 3 conditions are on the Rolle's theorem are not satisfying for a given function f of x, right? On this interval 0, 1. Okay? It is the Rolle's theorem is not for this case, Rolle's theorem is not valid, no? Okay, for this function is not valid, the Rolle's theorem. Okay? We can conclude that hence, right, each of 3 conditions, right? First condition is f is discontinuous, second condition f is non-differentiable, third condition is f of 0 not equal f of 1. Each of the 3 conditions of Rolle's theorems are not satisfied by the given function f of x satisfy the defined in the closed interval 0, 1. Okay, right. Hence each of the 3 conditions of Rolle's theorem are not satisfied by the given function f of x defined in the closed interval 0, 1. Defined in the closed interval 0, 1. Okay. Okay. Next question. Using Rolle's theorem, so that on the graph of y equal s squared minus 4x plus 3, there is a point between 1,0 and 3,0, yeah, tangent, right? Tangent is parallel to x-axis. Okay. Also find the point. Okay. That means they ask, by using the Rolle's theorem, you have the graph, right? Like this. From the picture description, you will easily understand. It is y-axis, it is x-axis. By using Rolle's theorem, so that graph y equal s squared minus 4x 3. What is the pattern of that graph? The cutting point for this one here, suppose here is there 1 0, no? X is 1, y is 0, and 3 is 0 here. Right. What is the graph for this one? Of the shape, this one you already studied, no? Here this tangent, there is a point between this point. This is 1, this 3. There is a point between this one. You assume that this point is C. You take this point is C. In this point, this tangent is 0. Here, not see here, where the tangent is parallel to the x-axis. Both are parallel. Tangent. Here this is perpendicular. Here also perpendicular. Okay. Right. Now they ask what is the value of C. From this equation, okay, from this equation, you can find this value and this value. Okay, right. Then you can apply the Rolle's theorem, you can find the value C. Understand? Right. Here they ask using the Rolle's theorem. Therefore, what is the thing you want to choose? There are 3 things you want to show that. The 3 conditions are satisfying, then you can easily use the Rolle's theorem, find this value C. Okay, that is a question. this graph patterns, but you know, for this graph you can easily draw this picture, but for some we'll do another example, but that example we can't guess the graph pattern. For this case, no, don't worry about this. You know this cutting point of x-axis is enough. Okay, understand? Okay. Sometimes this graph is pattern like this, but for this case, this pattern is this one. I think your ordinary level studied that part. Okay, right. Okay. Since here it is polynomial, no? Second order polynomial, is it okay? Since the given function is polynomial function, okay, since this function, since given function f of x squared minus 4x plus 3, is it okay? Yeah, 3 is polynomial function is it polynomial function, okay, is it polynomial function hence, okay, and hence this polynomial function is a differentiable function, and hence it is differentiable and continuous, differentiable and continuous function, right? Function, which interval here? Interval is 1 to 3, no? In function in 1, 3. Okay, 1 here, 3. This interval. Okay, right. So f is differentiable in the open interval 1, 3. Because f is differentiable in the closed interval 1, 3, but this open interval subset of closed interval, therefore f is differentiable in 1, 3. Now check the third condition. What is the f of 1 and f of 3? F of 1, I think you put here. F of 1, 1 minus 4, 3, 4, 4, 0. F of 3, 3 squared 9, 3 squared 9 minus 4 into 3, 12 plus 3, 12 minus 12, 0. From this one you have this one. Value is 0. If it's both are equal is enough, right? It don't be a 0 value, but some cases it is 0 values, no problem, right? Okay. Any values, for any values, but f of 1 equal f of 3, it's enough. Okay, right. Therefore, all conditions of the Rolle's theorem satisfied. Okay, all the condition of Rolle's theorem are satisfied. Then there exists, right? There exists a point, right? A point, this one, C, right? There exists a point. That value is xy coordinate values is suppose C, then you have FC. Is it okay? The point FC between which one? This one and this one. What is the point here? 1, 0, and 3 comma 0, right? Here 0, right? At which tangent is parallel to x-axis. So what is the condition? Tangent is parallel to x-axis. What is the condition? Tangent values. That means this f dash of that point C equal to 0. Okay, f dash of C equal to 0. Now your claim is you want to find the C value and FC value. C value and FC value. So first you have f of x equal s squared minus 4x plus 3. So take the derivative, put the point C, and this one equal to 0, no? Therefore your C is 2, I think. C is 2. Okay, now your point C is 2. So for in this point C equal 2, you want to find f of 2. 2 squared 4 into 2 plus 3 minus 1. Therefore, obviously, this graph pattern is correct because suppose you put here like this graph, but it's wrong no, because it's minus 1 values. They are only possible here. This is like this graph. Okay. In this question, they ask also find the point. No, that point is this one, right? This one is given 1 comma 0, 3 comma 0. This point, they ask this point. This point, they will ask. Thus, we get, and after this one, okay, after this one, you can write. And thus, we get the point which one? C is 2, f of C is minus 1, right? Which is required point. They will ask this point, right? Thus, this is required point, okay? Okay, it is the question, right? You can apply Rolle's theorem here also, right? Understand? So many application of the Rolle's theorem. This is also one of the application to find the point, okay? Next question. Next question. Next question. using the Rolle's theorem, prove that there is a point (1, minus 2) and 2, minus 2 on the graph of y equal s squared minus 3x, where the tangent is parallel to x-axis. Tangent is parallel to x-axis. Also find the point. Here also you want to use the Rolle's theorem. For this one, first you think about this question. The point here is 2, 1, sorry, here 1, here 2. You have the point here 1 minus 2, 2 minus 2. So, is it okay? Graph of the pattern like this. Okay. They mention another thing. This tangent is parallel to the x-axis here. Tangent is parallel to x-axis. Okay, tangent is parallel to x-axis. At that point, suppose you put this point C, at this point f dash C equal to 0. At this point f dash C equal to 0. Okay, they will ask what is this for here C, what is the FC values here. Okay. Therefore, you want to use the Rolle's theorem and you can find the values of C and FC value. Okay, that is the question. So, first given function, you want to verify 3 conditions. No, for using purpose of the Rolle's theorem, you want to check 3 conditions. First, given function f of x is squared minus 3x is polynomial function is a polynomial function of x. So f is differentiable and continuous function. So f is differentiable and continuous. F is differentiable and continuous. Right? What is the interval here? 1, 2. No? Interval in 1, 2. Therefore, f is differentiable and continuous in 1, 2. Is polynomial, no? Differentiable and continuous is 1, 2. Therefore, f is differentiable in the open interval 1, 2. So, what is the value of f of 1? F of 1 means 1 here, no? F of 1 means, right? F of 1 means you put this equation. s squared minus 3x, this equation. Okay, then 1 minus 3, I think minus 2. What about the f of 2? F of 2 means 2 squared, 4 minus 6 minus 2. From this 2, f of 1 equal f of 2 equal minus 2. Okay, there are three conditions of the three conditions are satisfying. Then you can actually use the Rolle's theorem. Therefore, all condition of Rolle's theorem are satisfied. All conditions of Rolle's theorem are satisfied. Then there exists a point. Suppose you put this point is C, then you get here C. This is function f of x, no? Suppose you put here C, this is function, this point value is here FC. That means C, FC, okay, between which point? 1 comma 1 minus 2 and 2, which point? Minus 2. 2 minus 2, right? At which the tangent parallel to the x-axis, no? At which, at this point, tangent, at which tangent is parallel to x-axis. Okay, that means this f dash of this one C equal to 0. From this one, you can find the point C value. For finding the point C values, take the derivative for this function. F dash of x first, 2x minus 3. Put the point C, this one equal to 0. 2c minus 3 equal to 0. Therefore, c equal to 3 by 2. Of which this 3 by 2 belong to open interval 1 comma 2, no? Because 1.5, yeah. What is the FC value? Because they ask the question, find the point. That means C FC value they will ask. FC means, put here. For C value is 3 by 2. 3 by 2 means 9 over 4. Put 3 by 2 here. Minus 3 means 9 over by 2. I think minus 9 by 4. Minus 9 by 4. Therefore, thus we get the point. Thus we get point 3 by 2 minus 9 by 4, which is the required point. okay, which is the required point. Okay, these are the some problems in Rolle's theorem. Okay.